There are countless stars and planets throughout the vast cosmos. However, there are over 1,000 active satellites only in our galaxy. Each of these gadgets is an incredible scientific marvel, capable of everything from spying on other countries to assisting us in surviving natural disasters. Satellites have revolutionized our world in ways we could never have imagined. They have improved our knowledge of the Earth, the cosmos, and even ourselves. Moreover, while satellites are undeniably a blessing, they are also a potential threat. As technology develops, the potential for abuse and misuse also increases. Governments and other organizations may use satellites for illegal activities. If you want to learn more about the satellite and how it has benefited our ecosystem and been a miracle, watch this video and to the very end. The space race between the United States and the Soviet Union began on October 4, 1957, when the former Soviet Union launched Sputnik 1, making it the first space power. The US was the second country to enter space. The United States launched Explorer 1 4 months after Sputnik 1 entered orbit. Explorer and Sputnik were not the first communication satellites. The concept existed earlier. Arthur C. Clarke first proposed using satellites in geosynchronous orbit for communication purposes in 1945. Together with Skynet, the National Aeronautics and Space Administration, NASA, launched an experimental aluminum-coated balloon in 1960. In this video, we will talk about miracles and the threat of satellites. Before we proceed, please give this video a thumbs up and subscribe to this channel for more content. In order to subscribe to new video alerts, click the bell symbol. Have you already put it into action? Let us continue. What is a satellite? An object placed into orbit in space on purpose is known as a satellite or artificial satellite. Most spacecraft, except passive satellites, contain a means of generating electricity for the technology they carry, such as solar panels or radioisotope thermoelectric generators, RTGs. The majority of satellites also feature transporters, which are a type of ground station communication system. The most common satellites, small CubeSats, use a standardized bus to reduce costs and labor. Satellites of a similar type can cooperate to form constellations. Satellites are made to be as light and as durable as feasible due to the high expense of space launch. Numerous transponders, each having a bandwidth of tens of megahertz, are carried by the majority of communication satellites, which are radio relay stations in orbit. Satellites are launched into orbit from the surface by high enough vehicles to prevent orbital decay caused by the atmosphere. The satellite's orbit can then be changed or maintained using propulsion, typically chemical or ion thrusters. In 2018, most satellites orbited the Earth in geostationary orbit, also known as low Earth orbit, where the spacecraft remains stationary in the sky. Because they can survey the entire planet with comparable lighting, some imaging satellites selected a sun-synchronous orbit. The risk of collision is growing as there are more satellites and space junk around the planet. Several bodies at once or a small number of satellites circle other bodies, like the Moon, Mars, and the Sun. 2 for a halo orbit, 3 for a Lissajous orbit. Earth observation satellites collect data for mapping, reconnaissance, and other purposes such as weather, ocean, and forest monitoring. Space telescopes use the nearly perfect vacuum of space to view objects across the electromagnetic spectrum. Communication satellites can transmit information to far-off locations because they can see a big section of the Earth at once. Satellite navigation systems like GPS use the satellite's signal delay and the predictability of their orbits. Space stations are essentially crewed satellites, while space probes are spacecraft built for robotic space exploration beyond Earth. On October 4, 1957, the Soviet Union launched Sputnik 1, the first artificial satellite into Earth's orbit. Early satellites. Intelsat, an international organization for satellite communications, was founded in 1964. A group of nations formed Intelsat, a cooperative to run communication satellites. NASA's SYNCOM-3 became the first geostationary communication satellite in August of that year. A few months later, in April 1965, Intelsat launched EarlyBird, a satellite that connected Europe and the United States with 240 telephone circuits and a shaky black and white television link. In 1969, Intelsat established the first worldwide communication satellite system after launching further satellites. On July 20th, 1969, Intelsat broadcast live television coverage of the momentous Apollo 11 lunar landing. One huge leap in communication technology, which has since continued to advance, made it possible for millions worldwide to hear Neil Armstrong's
That's one small step for man, one giant leap for mankind.
the first words ever spoken by a person on the moon. Around 1 billion people in 42 nations could watch World Cup soccer games in 1978 because of Intelsat's global broadcasting network. On April 13, 1974, Westar 1, the country's first domestic communications satellite, was launched into space. There were 120 transponders available in the United States by the end of 1976. Each transponder could offer one television channel and 1,500 telephone channels. The first network to use satellite technology to distribute content to its affiliates was the Public Broadcasting System, PBS. 24 stations in the southeast of the United States started receiving programming through a single C-band transponder on Westar on February 1, 1978. As a backup to the satellite, PBS continued to use telephone company lines for a month. The method was implemented throughout all PBS affiliates in the country after almost a year. These transponders were being used by PBS at the time to deliver time delay feeds to stations in various time zones. Satellite applications. Artificial satellites are space-positioned objects. They frequently impact our life without us recognizing them. For example, they keep us safe, offer contemporary conveniences, and broadcast entertainment. Here are a few tasks that satellites perform. Television. In addition to being the foundation of cable and network TV, satellites also deliver television signals directly to homes. These satellites transmit signals to smaller stations that transmit the signals locally over cables or the airways from a central station that produces programming. Satellite transmissions are also used for at-the-scene news reports, such as those sent from an accident or a live vote at the Capitol. Telephones. In addition to providing in-flight phone service for aircraft, satellites are frequently the primary means of voice communication in rural areas and places where phone lines have been damaged due to a disaster. Cell phones and pagers also get their primary timing from satellites. This dependence was made clear by a satellite failure in 1998, which temporarily silenced 80% of pagers in the US, prevented National Public Radio from distributing its broadcasts to affiliates and forced it to broadcast exclusively online, and caused Dan Rather's image to freeze on the CBS Evening News while the audio continued. Anyone with a handheld receiver can use satellite-based navigation systems such as a Navstar Global Positioning System, often abbreviated as GPS, to pinpoint her whereabouts within a few meters. In-car navigation systems increasingly include GPS locators, enabling ship making a challenging course in a harbor in heavy weather or troops being lost in uncharted territory, where other navigational aids may not be available. GPS-based systems are essential. Civilians and the military use them for land, sea, and air navigation. Satellites for business and financial communications can quickly communicate between several geographically separated locations. This crucial technology enables large manufacturing firms and department stores to manage their inventories, offer small towns rapid credit card authorization and automated teller services, pay at the pump gas at interstate gas stations, and video conferencing for global businesses. Weather. In order to follow the consequences of events like volcanic eruptions, burning gas, and oiled fields, as well as the development of huge systems like hurricanes and El Niño, meteorologists use satellites to view the weather worldwide. Environmental climate monitoring. One of the strongest data sources for studying climate change is satellites. Sea level has been rising by 3 millimeters each year for the past 10 years, according to data collected by satellite-borne radars, which also track ocean temperatures and currents. Due to the polar region's isolation and darkness, imaging satellites can measure the changing sizes of glaciers, which is difficult to perform from the ground. Satellites can identify long-term trends in precipitation, vegetation cover, and greenhouse gas emissions. Safety. The magnitude of forest fires, oil spills, airborne pollution, and ocean and wind currents can all be monitored by Earth observation satellites. This data, when combined, aids in the planning of emergency response teams and environmental cleanup. In remote areas, satellites can remove the search component of search and rescue. Rescuers can be guided swiftly and precisely to land, sea, or air emergency site via distress radio beacons connected directly to a search and rescue satellite. Land management. Satellites can find subterranean water and mineral sources, track the movement of pollutants and nutrients into streams, access the land and water temperatures, track the growth of algae in the ocean, and monitor soil erosion. Large-scale infrastructure that has to be monitored effectively includes fuel pipelines that need to be examined for leaks but would otherwise take countless hours of ground or air-based examination. High-resolution data of practically the whole Earth's landmass is produced by imaging satellites. In the past, access to such data was restricted to the military. However, Google Earth allows almost anyone with an internet connection to locate their home. Development. The importance of satellites is rising in developing countries. In a nation like India, where people are geographically and linguistically isolated, communication satellites give remote communities access to education and medical expertise that would not otherwise be available to them. Earth observation satellites also enable developing nations to manage resources intelligently and aid organizations in tracking the movements of the refugee population. Science and space. Before the space age, astronomers had to rely solely on ground-based telescopes to explore the cosmos, and they could only use data from the electromagnetic spectrum that could pass through the atmosphere of the Earth. Satellite telescopes have been essential to studying phenomena like pulsars and black holes in determining the universe's age. Many of the most interesting phenomena are best researched at frequencies that are best or only accessible from space. Undoubtedly, the Hubble Space Telescope is the best astronomical instrument ever created. Drawbacks of satellites. The price is prohibitive. The cost of satellites is high. The price of launching the satellite into space is in addition to the price of producing one of these gadgets. Even when launched successfully, satellites are expensive, yet launches go wrong much too frequently. In 2017, the rocket carrying the expensive spy satellite Zuma failed to lift it into orbit, resulting in its loss. As satellite technologies become more sophisticated for various purposes, satellite costs could increase. The reception of signals can be sporadic. The satellite's somewhat erratic signal is another issue. Various factors influence the reception and strength of a satellite signal. The satellite or anyone working on it could make mistakes. The transmission may experience varying degrees of interference as a result. Other factors that impact the satellite's transmission may be beyond our control, such as weather or sunspots. All these things can interfere with one another and make effective satellite operation exceedingly challenging. Delay in propagation is a problem. The time it takes for the satellite to communicate with Earth is known as the propagation delay. This lag can change significantly. The enormous distance mostly brings the satellite must travel to relay the signal. The time can range from 270 milliseconds to 320 milliseconds to go to and from the satellite from Earth. Or telephone connections, this delay could result in an echo. Conclusion. When they first began to be utilized, satellites transformed the globe in ways we could never have predicted. Satellites have significantly impacted our lives, from informing us about our surroundings to allowing us to interact globally. Satellites have a dark side, though, and that they can be employed destructively in conflict. We must comprehend the implications of our increasing reliance on satellites for daily necessities so that they might be used constructively rather than destructively. Today's video has come to an end. Give the channel a thumbs up and subscribe if you enjoyed the video. Remember to click the bell symbol to receive notifications when new videos are posted. I will see you in the next video. Until then, bye.